Hello there, and welcome to Science for Sleep, where curiosity slows down just enough to let the mind wander. Tonight, we're stepping into something so simple we almost never stop to think about it, and yet so strange that even physicists sometimes sit back and stare at the question like it's a riddle written in starlight. What does light actually see? If it could see anything at all. It moves faster than anything else we know. It doesn't appear to age. It never waits. And somehow, it's the quiet messenger that connects every corner of the universe. But before we start pulling at that glowing thread, I'd like to ask you something. Where are you listening from right now? Is it late? Is it early? Is the room dim? Or is there a little glow from a lamp or a screen painting the wall softly? If you'd like this to be the kind of quiet place where you can drift off while still learning something strange and wonderful, I'd be grateful if you gave the video a like, maybe even subscribed. It's an easy way to help this little corner of calm reach other night thinkers who might be staring at the ceiling and wondering about the speed of light too. Now, let's slow ourselves down just for a moment, because the thing we're about to talk about doesn't slow down at all. Light is odd, because it doesn't behave the way we do. If you imagine yourself sitting in a car or on a train, even when you're moving quickly, you can still look out the window and watch the world passing by. Trees bending in the wind, clouds drifting above the horizon. Everything is in motion but still knowable, still placed within time, but for light none of that happens. Not in the way we'd expect, at least. And to even begin to grasp that, we have to start with one strange fact. Something so deeply built into the universe that you can't talk about light without it. No matter how fast you go, no matter how hard you push, you can never catch up to it. It always moves away from you at exactly the same speed. If you're sitting in a car and you drive behind another car that's going slower, you can eventually pull alongside it. If you pedal your bike hard enough, you can catch a jogger. But with a light, that never happens. It doesn't matter if you're standing still or flying through space at tens of thousands of kilometers per hour. The beam of light coming off a distant star will still leave you just as far behind as before. It's as if it has no interest in meeting you halfway. It simply runs the universe at its own pace. This fact isn't just trivia. It's the key to why time and space bend themselves into shapes that don't make sense at first glance. Think about this. Light isn't simply fast. It is the fastest thing allowed by the laws of reality. And because it's the fastest, it sits at a strange border where our normal rules about time no longer seem to apply. If you were somehow able to ride along with it, to match it step for step, or rather photon for photon, you would stop noticing time passing altogether. There would be no before and after. There would just be everything all at once, in a kind of infinite present. It isn't that you'd move through time quickly or slowly. You wouldn't move through it at all. And this is where it starts to feel unsettling. Because light, in a sense, doesn't experience distance the way we do either. For you and me, walking across a room means moving from one point to another. It takes time. We have to cross the gap. But for light, that gap collapses to nothingness. If you were a photon born in the heart of a star, headed for the eye of someone looking up at the night sky, it wouldn't feel like a journey. It would just be a single, unbroken moment, leaving and arriving fused together into one. This is hard for us because we live inside time. We measure it by clocks, by meals, by the slow fade of sunlight at the end of the day. We need it to make sense of anything. And yet, from the perspective of light, if you can call it a perspective at all, that whole framework simply doesn't exist. So when we ask, what does light see? What we're really doing is peering across an enormous divide between how the universe looks to us and how it might look if you weren't bound by the things that hold us still, like mass, or waiting, or the slow tick of a second. And yet light is the very reason we can see anything at all. It carries every sunset, every spark, every reflection off a puddle. It moves without pause, connecting stars with planets and planets with eyes and cameras and telescopes. It shows us a universe that would otherwise be hidden behind a curtain of darkness. It may not age, but it allows us to watch everything else age around it. if you've ever looked at a star that's thousands of light years away, what you're really seeing is an echo, an image carried by photons that have been travelling for millennia, unbothered by the stretch of years between their beginning and their end. They don't know that they've been on the move for longer than every civilization we've ever built. They don't know anything at all, of course, but if we imagine for a second, if we let ourselves pretend, what would it feel like to exist in a state where there is no later, no sooner, just a single, unbroken now? And maybe that's why this question stays with people once they hear it, because it forces you to notice how strange light really is. We use it without thinking. We flick on lamps, we watch screens, we look at the sky. But all of it is built on this thing that behaves so differently from everything else we know. We live in a world where things have to push through time. Light lives in a world where time never quite touches it. And that's why starting here matters. Because to understand what light sees, if we can even use that word, we first have to step out of ourselves just a little bit. We have to imagine a way of existing that doesn't fit into the tidy boxes we're used to. The boxes where moments follow one after another and distances stretch out between them. If you follow light, you leave those boxes behind. You slip into a place where the universe itself seems to flatten, where motion doesn't cost time, and where speed stops being something you measure and instead becomes something you simply are. But that's only the beginning, because the deeper you follow this, the stranger it gets. And if we keep going long enough, we might find that asking what light sees isn't just about light, it's about us, and the strange, slow way we move compared to it. And so, if you're ready, if you're comfortable enough to let this roll over you gently, the way light rolls across the empty spaces between galaxies, then let's keep going. Because the universe has been travelling at this speed for as long as there has been a universe at all. And the only way to really understand it is to follow where it leads, without rushing, without stopping, just steady and quiet, like a photon on its way. Imagine for a moment that you're standing at the edge of a vast still lake. The surface is calm and you can see the reflection of the stars above, each one shimmering like a distant promise. The quiet is complete, and the stillness almost feels like it could last forever. But then, out of nowhere, you hear the faintest sound, the ripple of a stone skipping across the water. It's so subtle, so soft, but in that tiny moment, everything changes. The calm of the lake is disrupted, and for a brief second, you're aware of the energy it took to throw that stone, the force it took to create that ripple. You see that ripple stretch across the surface, distorting the still reflection, breaking the perfect stillness. But what's odd is this. The ripple isn't confined to one spot, it travels, it moves in waves, a little disturbance carrying its energy outward, affecting everything in its path. Now take that ripple and imagine it happening at the speed of light. It's not a stone. It's not a stone at all. It's the way everything in the universe communicates, a pulse travelling through space, faster than anything else, with a consistency that borders on the magical. No matter where you are, no matter what you're doing, that speed remains the same. Whether you're standing still or running at 1,000 kilometers per hour, light will always travel the same distance in the same amount of time. You could be on Earth, you could be on Mars, or you could be in a spacecraft heading toward a distant star. The speed of light is constant across every stretch of space. Now this isn't something you encounter every day. Think about all the other things that move, from cars to sound to even the blood pulsing through your veins. Everything else, by comparison, changes depending on the circumstances. If you're driving a car, the speed of the car is different depending on whether you're speeding up or slowing down. The speed of sound varies depending on the air temperature. Even the speed of a thrown baseball can be affected by wind resistance or the force you put behind it. But light doesn't play by those rules. It's immune to them. It's like a lone traveller who doesn't notice the changing winds, the shifting pressures, or the distractions along the way. It moves the same no matter where it's headed. This fact is one of the bedrock principles of modern physics. Light moves at an unchanging speed, and this speed is, incredibly, 297, 792, from 458 meters per second in a vacuum, or about 186, 282 miles per second. It's so fast that even the most powerful telescope in the world struggles to capture it, and yet it's so consistent that it's become the universal measure of all things. It's the foundation for all of our understanding of space, of time, and of motion. And the key thing is this: no matter how fast you move, no matter where you are, no matter how big or small you are, light will always race ahead, leaving you trailing in its wake. Why does this matter? Why does this strange, constant speed matter so much? The reason is simple, but profound. Light's speed is not just a characteristic of light. It is the speed at which information travels through the universe. When a star explodes, when a black hole bends space-time, when a new planet orbits its sun, that information is carried to us at light speed. The universe speaks to us through this pulse of light, from distant galaxies to the stars above our heads. This unchanging speed allows us to look backward in time, to peer into the past and see what happened when light was first released. It's like looking through the rearview mirror of the universe, only the reflection is not from yesterday but from millions or even billions of years ago. But this doesn't just apply to light. It applies to the fabric of the universe itself. Think about it. If light travels the same speed for everyone, everywhere, then time itself becomes tied to that speed. Time isn't some independent ticking clock that just marches along. It's connected to the way light travels. When you start to realize this, you begin to understand that speed isn't just something we use to measure motion. It's tied to the very structure of how everything in the universe works. And the fact that light's speed never changes, well, that's a clue, an anchor, that holds the entire structure together. For the ancient Greeks, the speed of light wasn't even a question. They didn't know about it, and they didn't need to. But for us, in the modern era, it's become a way of understanding everything, from the very start of the universe to how we explore distant worlds. It's one of those concepts that has forced us to rethink everything we thought we knew. It turned classical mechanics, the steady predictions of Newtonian physics, upside down. If light is always constant, then nothing can move faster than it. If nothing moves faster than light, then nothing can escape it, not even time itself. And this is where we run into something both frustrating and fascinating. You can think of light as the universe's ultimate limit. It's the maximum speed that everything can move. No particle can move faster, no spaceship can reach this speed. But what makes it stranger still is that light itself doesn't seem to notice any of this. To light, the passage of time doesn't even exist. It's as if, in its own journey, it has no concept of the space it covers, or the moments that pass along the way. The universe might age around it, but for light, it's an eternal now. Never in the past, never in the future, just constantly on its way. So, how does light manage this strange ability? The answer lies in its very nature. Light is not like a car speeding along a road. It's not like a ball being thrown through the air. It's not something that needs to accelerate, to slow down, or to change speed to accommodate the conditions it encounters. Instead, light is a wave. It's a pulse, a disturbance that carries energy across space. And when we think of it that way, we start to see how light can maintain its speed no matter where it goes. It's built into the very fabric of how it exists. It doesn't need to slow down or speed up because it is already in its perfect state of motion, and it will remain there as long as it moves through empty space. In fact, light speed is not just something that happens when it's on its way to us. It's a characteristic that defines how the universe behaves, in the same way that you can measure the temperature of water or the weight of an object. Light speed is a constant that determines the speed of every other process in the universe, and without it, everything else would fall apart. If light could suddenly change its speed, even by a tiny amount, the whole universe would change with it. The laws of physics would break down, time would stop, and the way everything moves would be lost. Yet despite all this, there's something strangely comforting about light's speed. It offers a sense of constancy in a world that is constantly shifting. No matter where you are or where you've been, light will always travel at the same pace, and when it finally reaches you, it will carry with it the secrets of the universe, from the ancient past to the endless future. When you think about it, there's something profoundly steady in knowing that light, in all its mystery, moves at the same rate no matter what. It's a reminder that in a universe where everything seems to change, there are still a few things that stay the same. So, as you lie there, drifting into rest, think about that constant, the speed that never changes, the pulse of light, travelling forever, never slowing, never hurrying, just continuing on its way. It's a strange, beautiful thing, one of the few truths we can count on in the vast unknowns of space and time, and when you look up at the stars or glance at your phone screen, know that the light that reaches you has already travelled farther than you can imagine, and it's still coming, still arriving, still moving at that strange, unchanging speed. Imagine for a moment that you're standing on the edge of a vast, boundless horizon. The sky before you stretches on forever, a tapestry of colours shifting, always in motion, and yet, for light, everything before it is already here. Everything is a single, continuous now, a moment that doesn't need to wait or pass through time. It doesn't need to be somewhere else. There is no tomorrow, no yesterday. There is only the now, where time stretches and contracts, bends and folds, but never truly changes for the photons that carry this light across the cosmos. This is a strange world, a world without waiting, a world where time does not behave as we know it. For us, the passage of time is everything. Every second, every minute, every hour is a precious part of our lives. We measure it, we experience it, we feel it slip away. We wait for it to unfold, and we often feel as though it's running out. We live with the expectation that time moves forward, that we move forward through it moment by moment. We understand that time is something we must navigate, a steady current that carries us along. But for light, time doesn't pass the way it does for us. When light travels from one point to another, it does so instantaneously in its own experience. The space between here and there might stretch across vast distances, from the farthest stars to the deepest corners of the universe, but for light itself, it never has to wait. There is no sense of before or after. There is no sense of journey, no sense of separation between one place and another. To light, all places are equally present. It doesn't need to move through time, it simply exists in a state of unchanging now. And this unchanging now is what makes light so uniquely strange. Because for everything else we know, time is a fundamental part of existence. We experience it, we measure it, and we age with it. We exist within time. It defines the way we experience the world, the way we interact with it. But light doesn't age. It doesn't wait. It doesn't experience the world the way we do. It exists only in its state of motion, constant, swift, and unyielding, never in one place for long, yet always present, always moving, always at the same speed. This concept is hard to wrap our minds around because we're so deeply rooted in the passage of time. We've designed our entire lives around the concept of waiting. The ticking of the clock governs our every decision. We wait for the bus, we wait for our turn, we wait for the day to end, we wait for tomorrow. We define ourselves by the milestones we move toward. But light doesn't know this waiting. It simply moves at its speed, effortlessly and continuously. From the moment it's born in the heart of a star to the moment it reaches your eye, light travels without interruption. Now think about this. If light moves through space at the same unchanging speed, then to experience the world from its perspective is to experience it as a single moment. The light doesn't know the space it crosses, because to it, space and time become indistinguishable. There is no before or after, there is only now. In a sense, light doesn't move at all. It is everywhere at once, but without experiencing the passage of time, This makes it an eternal traveller, a witness to everything, but without the burden of waiting for anything to happen. You can think of it like this. Time for us is a road, a path that we must follow. We take steps from one moment to the next, and every step is marked by the passage of time. But for light, the road doesn't exist. There are no steps. There is no journey. There is no movement in the traditional sense. Because for light, everything is happening at once. It is always at the destination. Because to light, there is no destination. There is only the unbroken moment of now. To understand this, you have to think beyond the usual rules of time. We tend to think of time as something that unfolds in a line, a constant progression from past to present to future. But this view of time breaks down when we start considering light, the fastest thing we know, the one thing that can move across the universe without slowing down. For light, there is no tomorrow, there is no yesterday, there is only an endless now, and that is where it exists. If you could ride alongside a photon, zooming through space at the speed of light, you would experience something very strange. You wouldn't age. You wouldn't feel time passing. You wouldn't need to think about the space between points, because there would be no space between them, only the single instant of movement. All distances would collapse into one single continuous event. There would be no beginning, no middle, and no end. There would be no time at all. This is what Einstein's theory of relativity helps explain. Time and space are part of the same fabric. When you travel at the speed of light, the rules of the universe change. Time stops. Everything becomes compressed into one eternal moment. But this is a reality that we can't experience because we are bound to move through time. We can't escape its effects. Time always marches forward for us, and we always march along with it. We wait for things to happen, and we mark the passage of time with our clocks, with our watches, and with our memories. But light is free. Free from the constraints of time. Free from the constraints of waiting. For light, everything happens at once. There is no delay. There is no past or future, only a singular, continuous moment. This makes light one of the most extraordinary things in the universe. It is both everywhere and nowhere, constantly in motion but always present in the now. This concept of a world without waiting, where time doesn't progress, is one of the most difficult to grasp. We are so deeply embedded in our experience of time that it becomes almost impossible to imagine a world where time doesn't exist in the way we understand it. But when we step outside of ourselves and consider light's perspective, we can begin to see how different everything would be without the passage of time. As you think about this, let yourself rest in the simplicity of it. Light doesn't rush to the next moment. It doesn't hesitate. It simply is. It moves at its own pace, a pace that never changes. There is no time for light, and in that sense, it is a part of a reality that we can only begin to understand. Light exists in a world where every moment is the same, and for that reason, light is timeless. So, while we wait for the next hour or the next day, light is already there, already here, moving through space, never concerned with the past or the future. It exists only in the present, where time is meaningless and waiting is a foreign concept. It shows us that there is more to time than we might ever understand, that sometimes the absence of time might be the key to seeing the universe in its purest form. If you could somehow match the speed of a light, a feat that would require some very creative physics, you would suddenly find yourself in a very different world. The space around you, once familiar and full of distance, would now seem to shrink in ways that are almost impossible to understand. Distance, that thing we rely on every day, the thing that measures how far we've come, would lose its meaning. Imagine, if you will, that you are zooming through the universe at light speed. You leave behind the familiar sights of Earth, the towering buildings, the winding roads, the little distances that fill our daily lives. But as you push farther and farther from home, something strange begins to happen. the very concept of distance starts to behave differently. It doesn't stretch out before you in the way it used to. It begins to contract, to compress itself into a kind of condensed space, pulling everything closer together. For you, travelling at the speed of light, the vast distances that once separated you from the stars, the millions of kilometres, the countless light years, would simply collapse. The sky, which once felt infinite, would seem no larger than a pinprick. The planets, once miles apart, would suddenly be as close as the nearest walls in a room. Everything would be compressed into a single instant, a moment in time that doesn't move forward because you're travelling at the very speed that makes time itself seem irrelevant. To understand this, we have to return to one of the most mind-bending aspects of Einstein's theory of relativity. According to his theory, when you move faster, the world around you changes, not just your perception of time, but the way space itself behaves. The faster you go, the more space, or rather the distance between objects, begins to contract in the direction of travel. The faster you move, the shorter the distances between you and your destination become. Now, imagine you are a photon, racing toward a distant star. From the moment you leave, you're already moving faster than anything else in the universe. But here's the trick. To you, the photon, the distance between where you started and where you're going doesn't stretch out like it does for us. There's no long journey. You don't see the space in front of you stretching endlessly. Instead, space itself has contracted. You are already at the destination the moment you leave, because to you, distance doesn't exist in the same way it exists for the rest of us. This is where the difference between your perspective and the perspective of someone on Earth becomes stark. From Earth, we see light travelling across vast distances. The stars seem far away, galaxies seem separated by unimaginable stretches of space. But for light, those same distances are non-existent. There is no in-between for it. There is no space separating the light from its destination. There is only a single, uninterrupted moment. What does this mean for us, as observers travelling at a fraction of the speed of light? It means that for us space stretches. The further we go, the more distance we perceive. A simple journey that should only take a few hours on Earth can feel like an eternity when we're moving through space at high speeds. This is the paradox of relativity. The faster we go, the more the distances stretch in our perception. But for light, there is no stretching. There is no in-between time. There is no waiting for the moment when you arrive. This concept is challenging because it forces us to rethink our everyday understanding of space. For us, space is vast, expansive, and filled with endless distance. But for light, space is a kind of illusion, a thing that contracts and bends the faster you move. It doesn't stretch out like we imagine, it simply collapses, and this is why light, in its infinite speed, doesn't experience the world the same way we do. This compression of space becomes even more apparent when you start thinking about travelling through space at nearly the speed of a light. If we were in a spaceship moving fast enough to experience relativistic effects, a journey at 99.99% of the speed of light for instance, we would see the distances between stars, planets and galaxies compress into a nearly impossible sliver. We would pass through light years of space almost instantaneously, all the while experiencing only a fraction of the time that an observer on Earth would. For us, the stars would seem incredibly close. The distance between us and any other point in the universe would shrink down as if we were sliding through a tiny crack between two gigantic walls. But here's the key. No matter how fast we went, the universe would still behave as if it had its own rules. For someone watching from Earth, it would appear that we were moving slower. Our journey would seem to stretch out because, from their perspective, time would slow down for us the faster we travelled. We would age more slowly, we would experience less time passing, but for us it would still feel like a regular journey. We wouldn't feel the change in our own perception of time because we would be inside that moment, experiencing it as we always do. But the rest of the universe, the rest of the world, would see us as frozen in motion. This is where the paradox of speed and time begins to unfold. The faster you go, the more space contracts in the direction you're moving. But at the same time, your own perception of time changes. For you, the traveller, the universe around you seems to move more slowly. But for those left behind, everything seems to speed up. It's as if the faster you travel, the more the universe adjusts itself to fit you into its narrative. The distance collapses, but time stretches. Everything adjusts in response to the unyielding speed of light. And this is why, when light travels through the universe, it experiences no distance at all. There is no getting closer to a destination, because everything is already part of the same moment. The light that leaves a star billions of years ago and reaches your eyes tonight doesn't see the journey in the same way you would. For it, there is no space to cross, no distance to measure. It's already there, it's already arrived, it's everywhere, all at once, travelling through time and space at the same unchanging pace. When we look at the stars, we're seeing a snapshot of the past, a moment frozen in time, held in the photons that have been travelling for eons. The distance between us and those stars doesn't exist in the way we imagine. What we're really seeing is a memory of light that began its journey long before we ever looked up to the sky. In this sense, light is a witness to the universe's history. It doesn't travel through space in the same way we would. It doesn't measure the distance between 2 points. It simply is. It moves, but it moves in a way that erases the space between things. It is always where it is meant to be, instantly, at once. And as you lie here, listening to this, perhaps you can begin to see how this changes everything. Light is not just a carrier of information. It's not just a means of seeing. It's a bridge that carries us across vast distances, compressing all the space between us and the stars, between here and there, into a single, unified now. The light that comes from the farthest reaches of the cosmos is already here. It has arrived, and in its journey it has stretched across time and space, leaving no distance between itself and the moment of your seeing it. This, then, is the paradox of light. It travels vast distances, yet never experiences them. It carries the universe within it, yet never waits for it. For light, there is no space and no time. There is only the now. A now that stretches and bends, shrinks and twists, but never truly moves forward. It is eternal, it is present, and it is always here. If you could travel at the speed of a light, what would time look like? Imagine yourself as a photon, a tiny massless particle of light, born in the heart of a distant star racing across the cosmos. As you travel, something remarkable happens. You stop experiencing time altogether. To the photon, time doesn't exist. There is no before or after, no sense of past or future. Everything is happening in the present, and that present is infinite. Now, you might be wondering, how can this be? We live our lives surrounded by clocks, calendars, and deadlines, always moving forward through time. For us, time is the thing that controls everything. It ticks forward relentlessly, and we move with it. But if you're a photon, time as we know it doesn't apply. The faster you move, and photons move at the fastest speed possible, 458 meters per second, the more time itself seems to dissolve. It's as if the universe has hit pause for you, and you experience a reality that stretches and bends but never quite moves forward. To understand this, we need to dive into Einstein's theory of relativity. One of its most strange and fascinating implications is the way it links time with motion. The faster you go, the slower time moves for you, relative to someone who's moving slower. This is called time dilation, and it's one of the fundamental results of relativity. When you're travelling at a speed close to that of light, the flow of time itself begins to change. The faster you move, the more your perception of time slows down compared to someone at rest. But here's where it gets mind-boggling. When you reach the speed of light, time essentially stops for you. For a photon, there is no passing time. It travels from one point to another, from one star to the next, from the surface of the sun to the earth, in an instant. But it doesn't experience any of the journey, because for it, there is no journey at all. There is no interval between departure and arrival. Time is not measured by the photon. It doesn't age, it doesn't wait, it simply is. So, what does it feel like to be a photon? Well, in a way, it feels like nothing at all. No passing moments, no gradual movement, no space to cover. To you, the photon, everything happens all at once. Every moment is the same as the last. No future, no past, no memories of where you've been or expectations of where you're going. You are, in some sense, outside time. You exist only in the present, forever. This leads us to a question that seems almost too strange to ask. Can we, as human beings, ever truly understand what it's like to experience this eternal present, this world where time simply doesn't exist? For us, time is woven into every thought, every feeling, every movement. It defines our experiences. But for light, time is not a river that moves forward. It's not a clock that ticks relentlessly. It's not even a line. Time, for light, is absent altogether. It exists, but it never passes. And this is the paradox that relativity presents. As you approach the speed of light, the concept of time becomes increasingly harder to grasp. To an observer on Earth, someone travelling near the speed of light will age more slowly. Their clock will tick more slowly, and their experience of time will stretch out. But for the photon, time doesn't move. It simply is. It is everywhere, and yet nowhere. It exists, but doesn't move. It's a moment that stands still. What does this teach us about our own understanding of time? We experience time as a steady flow. We count seconds, minutes, hours. We measure everything in terms of time. But for a photon, time is a concept that doesn't apply. It isn't that time doesn't exist for the photon, it's that time behaves differently when you travel at the speed of light. To the photon, time is irrelevant. It doesn't age, it doesn't experience moments, and it doesn't need to wait. It is timeless. This is the true beauty of relativity. It forces us to reimagine the world we live in. We think of time as something that moves forward, something that dictates how we experience life. But when we look at it from the perspective of a photon, we see that time is more than just a constant progression. It's not just a clock ticking down. Time is a flexible concept, shaped by motion, by speed, by the speed of light itself. And when we approach the speed of light, when we become like the photon, we step outside of time altogether. It's hard to imagine what it would be like to experience life this way. Our brains are wired to think in terms of time. We live in time, we measure it, and we track it. But for a photon, all that changes, there is no clock, there is no passage of time, there is no before or after, there is just now, just this endless, eternal moment. For us, time defines the way we understand the world. It's the lens through which we see everything. But light, in its infinite speed, doesn't see the world the way we do. It doesn't need time. It doesn't need space. It exists in its own realm, where everything happens simultaneously. It is both everywhere and nowhere, stretching through space and time without ever truly experiencing either. In a sense, the photon teaches us that time is not an absolute, unchanging force. It's a relative experience. It bends, it stretches, it changes depending on how fast you're moving. But at the speed of light, time doesn't exist at all. It's frozen, it's paused, it's infinite, but it's also a kind of eternity that we can never fully comprehend. So, next time you look up at the stars and think about the light travelling through the universe to reach you, remember this. That light isn't just coming from a faraway place. It's coming from a realm where time has no power. It's coming from a timeless existence where the universe is both everywhere and nowhere, where the present stretches out infinitely, and where the very idea of waiting simply doesn't exist. For light, there is no past or future. There is only now, and in that now everything is connected. Instantly, effortlessly, eternally. Imagine embarking on a journey, but instead of feeling the familiar sensations of travel, the bumps of the road, the hum of an engine, the gradual unfolding of landscapes before your eyes, you experience nothing at all. There is no movement. There is no passage of time. There is no distance between you and your destination. Instead, the moment you start, you are already there. The journey exists, but it doesn't feel like a journey at all. It is more like the act of existing, but without the need to travel. This is what happens when light moves. It doesn't feel the journey, because it doesn't move in the way we understand movement. It's not that light doesn't travel, but the very concept of travelling loses its meaning when you move at the speed of the light. For light, there is no distance between 2 points. There is only one continuous moment, without gaps, without delay. It's as if the journey from one star to another is instantaneous. Yet this feeling of instant can't be understood from our human perspective. For us, a journey is something we experience in time. When we travel, we move through space, and space is something that stretches between one point and another. There's a beginning, a middle, and an end. There are moments where we're closer to our destination, and moments when we're farther away. We calculate time by the distance between those moments, measuring each step as we go. But light doesn't calculate time in this way. It doesn't experience space or distance the same way we do. For light, there is no getting closer to a destination, because there is no space to cross. Imagine if you could travel in a straight line from Earth to a distant galaxy, but instead of gradually moving through the space between you and your destination, you could somehow condense the entire journey into an instant. The concept of travel would lose all meaning. The entire journey, from beginning to end, would happen at once. You wouldn't be able to measure how long it took, because for light, it never took time at all. Time simply stops when you move at the speed of light. To the photon, there is no sense of going anywhere. There is no awareness of the path being travelled. It doesn't know it's leaving one place and heading to another. There is no distance for it to cover because it experiences the entire journey in one single moment. It is always where it needs to be, instantly. It's a journey that isn't really a journey at all. It's like a loop that folds upon itself, constantly completing and starting again in a way that makes the idea of travel meaningless. This idea of a journey without a journey is one of the strangest concepts in the realm of physics. We are so used to measuring our lives in the increments of time, ticking seconds, minutes, and hours, that it's almost impossible to imagine a state where time doesn't operate in this way. We're bound to move through time, bound to experience the passage of time as we go from one point to another. But light is different. For light, there is no through time. There is no moving from one moment to the next. There is only one moment, one continuous instant. It's as though light exists in a state of perfect unity with the universe, unaffected by the passage of time that governs everything else. It moves without moving. It travels, but it doesn't feel the journey. It simply is, always arriving as soon as it leaves. This is the essence of what it means to be a photon, a journey without a journey. It doesn't need to go anywhere. It just is. The consequences of this perspective are profound. If light experiences the world in this way, then how do we, as beings who are so deeply tied to the passage of time, make sense of the universe around us? We see light as a messenger, carrying information from one place to another. But that information is always arriving in the present, always part of the same eternal now. Light doesn't experience time like we do. It doesn't need to wait to reach its destination. It is already there. And yet, to us, it carries meaning. It carries history. and it carries the entire story of the cosmos from the moment of its creation to the instant it reaches our eyes. This creates a paradox. The light we see is a snapshot of the past, yet it reaches us in the present. When we gaze up at the stars, we are looking at light that left those stars billions of years ago. Yet in that moment, it appears as if the star is still there, still shining, still sending us its message. But to the light, the star has already disappeared. The moment it was emitted is forever entangled with the moment it arrives at our eyes. There is no time between the two. There is no waiting. There is only the now. This paradox helps to reveal just how deeply we are bound by the passage of time, and how profoundly different light's experience of the universe is. For us, everything is measured by time. Every step is an interval. Every event takes time to unfold. But for light, there is no interval. There is no unfolding. There is no time at all. And yet, despite this strange and unique way of existing, light is the key to understanding the universe. It connects us to the past, to the stars, to the distant galaxies that have long since ceased to exist as we know them. Light tells us the story of the universe, but it does so without ever experiencing the passage of time itself. It is a witness to everything, but a witness who doesn't feel the weight of waiting or aging. It is timeless, and it carries the universe with it in a way that nothing else can. So, as you lie there in quiet thought, imagining yourself as a photon, moving effortlessly through space without the burden of time, remember this. The universe is full of things we can never experience the way light does. We live in time, we move through it. But light doesn't move, it simply is. And in that timeless now, everything is already connected, already whole. There is no distance, there is no waiting, and there is no journey, just the eternal present. And maybe, just maybe, that's the way the universe is meant to be. If you think about the journey of light, one thing becomes immediately clear. Light travels in a way that seems almost effortless. It moves across vast distances without slowing down, unaffected by obstacles, and constantly racing toward its destination. But as we consider this seemingly free journey, something important stands out. Light has no mass. It's the massless nature of light that allows it to move the way it does, unimpeded by the same forces that bind everything else to the ground, that drag us through the fabric of space and time. Mass, in a way, is the thing that makes everything else move through time. It's what gives things weight, what gives them substance, what ties them to the rules of our universe. In fact, mass is the very thing that defines how objects interact with each other, how they move, and how they experience time. But light has none of this. It isn't bound by the same rules. It doesn't experience time in the same way, and it doesn't carry the burden of mass. Think about a simple object, something with mass like a ball. When you throw a ball, it takes time for it to move from one point to another. You feel the weight of the ball in your hand. You feel its resistance as you push it through the air, and while it's in motion, it experiences time. Every second, every moment it travels across the space between you and its destination. It's tethered to time in a very real way because of its mass. It moves slower than light. It's affected by gravity, it takes up space, and its mass plays a huge role in how the universe interacts with it. But now think of light. It doesn't have this weight, this mass. It doesn't experience the resistance of the air. It doesn't slow down, even when it passes through a gravitational field. It moves through space and time, but it doesn't experience either in the same way. Because light has no mass, it doesn't interact with space the same way that objects with mass do. It's free to travel without slowing down, without accumulating energy or dragging anything behind it. It's almost like it's unbound from the very fabric of the universe. Or at least it doesn't experience the universe in the same way that objects with mass do. This idea of light moving freely, unimpeded by the normal rules that govern everything else, is one of the most striking consequences of Einstein's theory of relativity. He showed us that mass, like light, bends the fabric of space-time, but in a different way. While light moves through space-time effortlessly, mass distorts it, causing time to stretch and space to warp. The more mass an object has, the more it distorts the space around it, slowing down time for everything caught in its gravitational pull. Imagine this. You're standing near a massive planet, like Earth. The gravitational field pulls on everything nearby, but if you were to jump into a beam of light, to be that photon racing through space, you would feel no such pull. You wouldn't experience the slowing of time that objects with mass would. In essence, mass leaves behind those who travel at light speed because mass and light operate on entirely different levels. Where mass pulls on space-time, light simply glides through it, unaffected by the curves and distortions that mass creates. This is why mass is left behind in the universe. As objects with mass move faster, they begin to experience more resistance from space-time. The faster you go, the harder it becomes to keep moving. Time slows down for you. You can't break the speed of light, no matter how much energy you pour into it. But light, because it has no mass, can move through space-time without being affected by this resistance. It's always moving at the same speed, no matter the conditions around it. Mass and light, in a sense, are the two great opposites in the universe. Mass bends space-time, pulling everything with it. It affects everything in its path from planets to light itself. But light, with its massless nature, moves through that space-time unaffected. It travels through the universe with a freedom that no object with mass can match. And this is why light is such a fundamental part of our understanding of the universe. It's not just a messenger that carries information. It's a constant, unchanging force that helps define how the universe operates. While mass and gravity shape the world around us, light is the one thing that moves through the entire structure of the universe, always at the same speed, always unaffected by the forces that bind other things. If you've ever watched a beam of light travelling through a dark room, or seen sunlight shining through the trees on a cloudy day, it's easy to forget that light doesn't follow the same rules we do. We see it, we feel it, and we experience it every day. But light, in all its simplicity, is free from the constraints that tie everything else together. It moves without waiting. It doesn't experience time. It doesn't carry mass. It's both everywhere and nowhere, racing across the universe, unburdened by the limitations that affect all other objects. In fact, it's not just that light is fast, it's that it is free. Free from mass, free from the passage of time, free from the limits that govern the rest of the universe, and that freedom allows light to do what no object with mass can. It can travel without restriction, moving through the cosmos at the same unchanging speed, from one place to another, without the need to feel the journey. So the next time you watch a beam of light stretch across a room, or imagine the vast journey that light has taken to reach you from a distant star, remember this: it is light's massless nature that allows it to travel freely through space-time. It moves without resistance, it is unbound. And in that freedom, light does something that mass can never do. It leaves the rest of the universe behind. It is a traveller in a world where time doesn't apply, a witness to the cosmos, always moving, always present, but never slowed down by the forces that bind the rest of us. Imagine for a moment that space itself, the vast, seemingly endless expanse between everything in the universe, isn't as solid as we think it is. Picture it not as something that stretches infinitely in all directions, but rather as something much more pliable, more delicate, something that, under the right conditions, can bend, fold, and compress, like a piece of paper being folded in half. What would happen to everything around us if space could bend like that? This is the strange world of Einstein's theory of general relativity, where space and time are not fixed entities but can be moulded, shaped, and stretched. In this view, Space is not the unchanging background against which everything moves. Instead, it's an active participant in the universe's dance. It stretches and contracts, molds itself to the objects within it, and reacts to the forces exerted by mass and energy. It's not rigid or static, it's flexible, malleable, and often it behaves like a fabric that can be stretched until it thins out to almost nothing. Think about a trampoline for a moment. When you stand on it, the fabric stretches beneath your feet, and the more weight you apply, the more the trampoline curves under you. Now imagine that, instead of standing on a trampoline, you're standing on the fabric of space itself, and every object with mass, whether it's a planet, a star, or even light itself, is a little weight pressing down on that fabric. The bigger the object, the more it bends the space around it. The more space bends, the more everything else is affected by it. It's a cosmic dance where mass and space-time are entwined, each pulling and stretching the other. But what happens when space bends too much? What happens when it becomes so warped that it stretches into a point of nothingness, where distances seem to collapse entirely? This is where black holes come into play. A black hole is the ultimate expression of space becoming paper thin. It's an area of the universe where the gravitational pull is so intense that the fabric of space itself bends to the point where it collapses inward, creating a point of infinite density known as a singularity. The closer you get to this singularity, the more space itself seems to shrink, like the surface of the trampoline being pulled tighter and tighter beneath you until it's impossible to measure distance at all. At the event horizon of a black hole, the fabric of space-time becomes so stretched that from the perspective of someone outside the black hole, nothing can escape, not even light. And that's what makes black holes so fascinating and so mysterious. They're regions where space and time blur together in a way that our understanding of the universe can barely keep up with. It's as if space has become so thin that it's no longer a place where things can move, but instead a point where everything stops. Now imagine this from the point of view of an object or a photon that is falling toward the event horizon. From their perspective, space is still unfolding in front of them, but as they approach the singularity, they will experience space stretching out in strange ways. They might feel time slow down, they might see distances shrink, and in some interpretations they might even experience a kind of flattening of the universe, where everything starts to appear as if it is compressed into a single, thin layer of space. It's as though the entire universe begins to fold itself in on itself, as if space is running out of room to expand. This idea is a fascinating one because it challenges everything we think we know about the nature of space and distance. We are so used to space being this thing that stretches infinitely, a backdrop for the events of the universe, but in the strange realm of black holes and extreme gravitational forces, space doesn't behave like that at all. It bends, twists and warps. It becomes thinner and thinner as gravity intensifies, until eventually it becomes so compressed that the very idea of distance loses meaning. The edges of space and time begin to fray, and the universe becomes something incomprehensible. The thinness of space at the event horizon of a black hole represents the very limit of what we can understand about the universe. But this doesn't just happen at black holes. In fact, the idea that space can be compressed to such an extreme degree is something that happens all around us, albeit in less dramatic forms. For instance, the faster an object moves, the more its journey through space is affected by the warping of space-time. As we approach the speed of light, distances begin to compress. Time itself begins to stretch and change. Space itself becomes thinner, and the world around us begins to distort. If you could somehow travel at nearly the speed of light, you would experience the universe differently. Stars would appear closer. The distances between galaxies would shrink. Space itself would seem to collapse, and the very idea of how far something is would become harder to grasp. This is the reality of relativity. Space is not a fixed, immutable backdrop for the universe. It's a dynamic, malleable fabric that stretches, bends, and reshapes itself in response to mass and energy. When objects with mass move through space, they distort it, creating ripples and warps that can stretch across vast distances. These distortions are felt by everything that moves through space, from the smallest particles to the largest galaxies. The universe is not a flat, static place. It's a place where space is constantly being pulled and stretched, folded and compressed, like a sheet of paper being bent by the weight of the objects placed on it. And the more we learn about how space behaves under these extreme conditions, the more we begin to realize just how strange and wonderful the universe is. Space, that thing we take for granted as the setting for everything we know, is not a simple, unchanging thing. It's a fabric, a living, breathing entity that responds to the forces around it. It's not just a stage for the drama of the cosmos, it is the drama itself. So the next time you look up at the night sky or think about the vast distances between stars, think about space bending and folding like a sheet of paper. Think about how, when you look at something so far away, you're looking at a universe that is constantly changing, constantly stretching, constantly reshaping itself. You're not just looking at stars, you're looking at the very fabric of the cosmos, moving, bending and thinning with every passing moment. In the grand tapestry of the universe, light is both a messenger and a boundary marker. It connects us to distant stars, it carries the stories of galaxies far beyond our reach, and it paints the world around us in vibrant colour. But light isn't just a simple force, it defines the edges of our reality. The moment light travels from one place to another, it reveals something crucial about the universe, the boundaries of what we can see, what we can know, and ultimately what we can understand about the world and beyond. Light, in all its strange and beautiful simplicity, sets the limits of our perception. It is the bridge between us and the vastness of the cosmos. Without light, we would be left in a universe of total darkness, unable to comprehend the depth, the size and the movement of the worlds around us. Yet light, as it travels through space, also creates the very boundaries of what we can know. It's the pulse that tells us where something is, how far away it might be, and what it might look like. But it also leaves a veil of mystery in its wake, as the limits of light's reach mark the edges of our understanding. Consider this. When you look up at the night sky, what you're seeing is not the stars as they are in the present, but as they were when the light began its journey. That light has travelled across vast distances, perhaps millions of light years, before it finally reaches your eyes. By the time it arrives, the star you're looking at might no longer exist in the same form, or even at all. But the light remains, carrying with it a message from the past. In that sense, light doesn't just illuminate the present, it carries the echoes of the past across time, allowing us a glimpse into moments long gone. The boundary between now and then is defined by the speed of light, the limit beyond which we can no longer see. This brings us to the boundary that light sets in our perception of reality. We often think of light as the thing that allows us to see the world, but light is more than just a tool for sight. It defines the limits of our physical universe. Light sets the edge of what is visible and measurable. The moment light is blocked or absorbed, we lose our ability to see what lies beyond. It's as though light creates a curtain that separates what we know from what we can never fully comprehend. We can only understand the universe in terms of what light reveals to us. Everything beyond that is hidden, waiting for the next photon to carry the message. And this boundary isn't just physical, it's also fundamental to the way we understand the universe itself. In the same way that light defines the edges of space, it also marks the boundaries of our perception of time. Light moves at a constant speed, and this speed is intertwined with the very structure of space-time itself. As light travels, it carries not just information about where something is, but also about when it was. The speed of light forms the backbone of our understanding of time. It defines the distance between events, the relationship between cause and effect, and the very flow of moments. But here's where the boundaries become blurry. If light is the key to understanding space and time, then what happens when we push the limits of light's reach? What happens when we approach the speed of light? Or, more intriguingly, when we encounter objects that light cannot escape from? This is the realm of black holes, the places where the boundaries of reality itself begin to break down. In these regions, light's journey is halted. The space-time fabric becomes so warped that not even light can escape its gravitational grip. In these places, the boundary between what we can observe and what we cannot disappears. We are left with a universe that is fundamentally unknowable, a region where light and the information it carries is forever trapped. It is in these regions, in the event horizon of a black hole, that we encounter the ultimate boundary. Beyond that point, we can no longer see or understand what happens. The information that light would carry to us is lost, swallowed up by the black hole. It's as if space itself folds in upon itself, closing the door on everything that lies beyond. And this raises a profound question. What does it mean for our understanding of reality when light, the very thing that connects us to the universe, is unable to reach us? This question becomes even more pressing when we consider the nature of the black hole's singularity, where the fabric of space-time is thought to collapse into a point of infinite density. Here, the very rules of physics as we understand them cease to operate. The boundary between known and unknown becomes a chasm so deep that even light cannot cross it. And yet, while we cannot observe the inside of a black hole, we are still aware of its presence, aware of the boundary it creates in the fabric of space. The very fact that light cannot escape gives us clues about the forces that govern the universe at its most extreme. The boundary is not a simple separation. It's a profound statement about the nature of reality itself. Outside the black hole, we live in a universe defined by the reach of light. It marks the farthest edges of space that we can perceive. It illuminates the vast expanse between us and the stars, allowing us to chart the cosmos. But inside that boundary, in the deepest, most mysterious places, light cannot go. We are left with only the boundaries that light sets for us, and the endless questions that arise from what lies beyond those limits. The boundaries of light are not just physical, they are metaphysical. They are the edges of what we can know, what we can see, and what we can understand. They define the limits of human knowledge, the boundaries of our exploration of the universe. They set the framework within which we operate, and beyond those limits lies a vast, unexplored world that we can only imagine but never truly see. And yet, light is still the key to all of this. Even though it sets boundaries, it is also the force that allows us to see beyond them. It is the bridge that connects us to everything we know and everything we don't. Without light, we would be lost in darkness, unable to fathom the vastness of the universe. But light, in its infinite travels, reveals to us the very edges of reality. It illuminates the universe, showing us what we can see and leaving the rest of it just out of reach, waiting for the next photon to come along and carry its message. Imagine for a moment that you're looking at the world through a fog. It's not the kind of fog that clouds your vision, but a haze that softens the boundaries between everything, blurring the lines between things that seem different, even opposites. You can no longer clearly define what is what, and yet everything is still there, existing together, in a strange state of coexistence. This is how light behaves in the strange, mysterious world of quantum mechanics, both a wave and a particle, existing in a haze where the rules of classical physics no longer apply. For centuries we understood light in one way. It was a wave, a smooth, undulating ripple that carried energy across space. Much like waves on the surface of water, it would bend around corners, spread out in all directions, and create beautiful patterns when it encountered obstacles, like when it passes through a narrow slit and spreads out to create interference patterns. This wave-like nature of a light seemed to explain so much about the way it behaved, from the colours we see when light passes through a prism to the way it interacts with materials. It was predictable, it was orderly, and it made sense. But then, in the early 20th century, scientists started observing something strange. When light interacted with matter, when it struck atoms or particles, it didn't behave like a smooth wave anymore. Instead, it seemed to behave as if it were made up of tiny discrete packets of energy. These packets were called photons, and they seemed to behave like particles, not waves. They could be absorbed by atoms, transferred from one place to another, and even counted one by one, like small individual balls of energy. How could light be both wave and particle? How could it fit into two worlds at once, each with its own rules and behaviours? This is the core of the mystery in quantum mechanics, where the very fabric of reality becomes flexible, blurry, and deeply counterintuitive. The quantum haze is the state of being in which light can no longer be confined to one category or the other. It refuses to be simply a wave, and it refuses to be simply a particle. It is, in its essence, both, and yet neither. The realization that light could be both a wave and a particle was a game changer for physics. It forced us to rethink the fundamental nature of reality itself. In the quantum world, things don't always behave the way we expect them to. Particles can exist in multiple states at once, and waves can act like particles. The familiar categories we use to understand the universe — solid, liquid, gas, wave, particle — all blur together in ways that defy our usual thinking. To understand why light behaves this way, we have to look deeper at the nature of the universe. In the world of quantum mechanics, everything is governed by probabilities, not certainties. This means that particles like photons don't have a definite position, momentum, or behaviour until they are observed or measured. Until that moment, they exist in a state of possibility, a haze of potential, in which they can be both wave and particle simultaneously. This strange duality is known as wave-particle duality, and it lies at the heart of quantum physics. When light behaves like a wave, it spreads out, interferes with other waves, and creates beautiful patterns. This wave-like nature explains the colour and intensity of light, as well as phenomena like diffraction and refraction. But when light behaves like a particle, it interacts with matter in discrete quantized steps. It transfers energy in specific amounts, like a ball bouncing from one place to another, and it can be absorbed or emitted by atoms in fixed amounts, rather than continuously. This duality between wave and particle is not limited to light. It applies to all quantum objects, electrons, protons, and even atoms. At the quantum level, things are never fully one or the other. They exist in a superposition of possibilities, each one waiting to be realized depending on how the system is observed. This means that light in its purest form is not one thing or another. It is both wave and particle, simultaneously existing in multiple states, depending on how it is measured. The moment you try to measure it, to pin it down, to define it, it chooses a state, either wave or particle, but until then, it exists as a haze of probabilities. This blurry state of existence might seem strange and difficult to grasp, but it's part of the very fabric of quantum reality. In the quantum world, nothing is fixed, nothing is certain, and everything exists in a fluid, ever-shifting state. Light doesn't follow the rules we've established in our everyday experiences. It refuses to fit into simple categories. It moves between the world of waves and particles as if the two worlds are connected, interwoven, and part of a larger, deeper reality that we can barely begin to understand. This wave-particle duality challenges the very notion of what light is. Is it a wave spreading through space like ripples on a pond? Or is it a particle, a discrete packet of energy, travelling through space in a straight line, interacting with matter one step at a time? The truth is, it is both, and neither, all at once. Light exists in a state of quantum haze, a liminal space where it is free from the strict rules we apply to the macroscopic world. This quantum haze extends beyond light itself. It defines the very nature of reality. In this haze, things are not fixed and measurable until we observe them. Until we measure the state of a quantum system, It exists in a state of possibility, a haze of uncertainty. It's not that we don't know the answer. It's that the answer doesn't exist in a definitive form until we ask the question. Reality itself, at the quantum level, is not a series of hard and fast facts. It's a dance of probabilities, a haze where multiple possibilities coexist until observation forces one to emerge. So the next time you look at a beam of light, remember this. It is not just a simple thing. It's both wave and particle, both something and nothing, both here and not here. It exists in the quantum haze, a place where the usual rules don't apply, a place where light can be everything and nothing at once. It's a reminder that the universe is much stranger than we often realize, and that the boundaries of reality itself are more fluid, more uncertain, and more beautiful than we could ever imagine. There is something unsettlingly beautiful about the idea that two things, separated by unimaginable distances, can still remain connected. This is not a metaphor. It is not poetic language. It is a real, measurable phenomenon, and it sits at the heart of quantum mechanics. It's called entanglement, and it stretches our understanding of reality to its breaking point. Imagine two photons born together in a single event, perhaps deep in the core of a star or in a laboratory experiment here on Earth. From the moment of their creation, they share a link, an invisible thread that connects them in a way no distance can erase. You could take one of those photons and send it across the room, across the planet, or even across the galaxy, and still, this strange connection would remain. If you measure one of them, you instantly know something about the other, no matter how far away it is. This is not just a clever trick. It's not a quirk of our limited understanding. It's one of the most experimentally verified facts in quantum mechanics. Einstein himself was so troubled by this that he called it spooky action at a distance, as if even he, the man who reshaped our understanding of space and time, couldn't quite accept that reality might be this deeply interconnected. And yet, experiment after experiment has proven that this thread, this quantum entanglement, is real. Here's how it works. When two particles become entangled, their properties are no longer separate. They become part of a shared quantum state. If one particle spins in one direction, the other will spin in the opposite, perfectly correlated no matter how far apart they are. The moment you measure one, the other knows, instantly, as if space and time between them simply doesn't matter. From our point of view, this seems impossible. We're used to the idea that information has to travel through space, bound by the universal speed limit, the speed of light. But entanglement ignores that limit. It's not about information being transmitted faster than light. It's about there being no between to travel through in the first place. The two entangled particles are not separate objects exchanging messages. They are in a very real sense one system stretched across space. This is where the idea of threads beyond time begins to take shape. If entangled particles are part of the same unified system, then our usual ideas of distance and time don't apply. You can't say that one particle affects the other, because at the quantum level, they are not truly apart to begin with. They exist in a state of unity that doesn't care about the boundaries of space or the flow of time. Now imagine this happening not just between two particles, but on a cosmic scale. Some physicists have speculated that entanglement may be woven into the fabric of the universe itself, binding particles, fields, and perhaps even regions of space together in ways we can barely comprehend. If that's true, then reality is not a collection of isolated objects drifting in empty space. It's a web of relationships, a vast network of invisible threads connecting everything to everything else, beyond the reach of distance or the tick of any clock. Think about what that means for light. Every photon that has ever existed might not be a solitary traveller, but part of a much deeper pattern. Even the light that reaches your eyes, light that has crossed millions of years of empty space, might be tied in some way to other photons, other particles, other events, through this strange, timeless quantum connection. Entanglement doesn't just blur the line between here and there, it challenges the very way we think about time itself. When two particles are entangled, their relationship doesn't unfold over time. It is instantaneous, immediate, and outside of any temporal sequence. The effect isn't delayed, it doesn't happen, it simply is. And in that way, entanglement gives us a glimpse of a reality that doesn't move through time the way we do. A reality in which events are not chained together in a neat line, but exist in a state of simultaneity that defies everything we know. What's more unsettling is that this isn't just a philosophical idea. Quantum experiments have shown again and again that no matter how far apart entangled particles are placed, their connection remains. Separate them by a few inches or separate them by entire continents, and the result is the same. One measurement here is reflected there, as though the space between them has been erased, folded up into nothing. This is why some scientists now wonder if entanglement might not just be a strange quirk of quantum physics, but the fundamental glue of the universe. If everything is connected at this deep level, then time and space might only be secondary features, illusions that emerge from something deeper, a web of connections that underlies everything. Light itself might be a manifestation of this web, a way in which the universe reveals its underlying unity. And if that's true, then entanglement doesn't just challenge our view of the world, it challenges our place in it. It suggests that nothing is ever truly separate, that every particle, every photon, every speck of existence is part of an unbroken whole. We live in a universe of invisible threads, and those threads stretch not just across space, but beyond the limits of time itself. So, the next time you imagine a beam of light crossing the darkness, think about what might be hidden beneath it. A network of unseen connections that binds everything together, indifferent to the distance between galaxies or the ticking of clocks. Perhaps this is what light sees in its timeless journey, not a universe of separate things scattered across empty space, but a single, seamless reality, tied together by threads we are only beginning to glimpse. Everywhere in the universe, light travels freely, racing across empty space without pause or resistance. It moves from stars to planets, from galaxies to our eyes, never slowing, never tiring. And yet there are places in the cosmos where even light, this unyielding messenger, must stop. These are the horizons, the ultimate edges of reality, where light meets boundaries it can never cross. The most famous of these is the event horizon of a black hole. Imagine it like a cosmic cliff, a point of no return. On one side, light can still escape, still move through the universe, carrying its message to distant observers. But once it crosses that invisible line, it is trapped forever. No matter how fast it moves, and nothing moves faster than light, it cannot climb back out. It is as if the universe itself draws a boundary there, a place where the rules change completely. From the outside, the event horizon looks deceptively simple. There's no visible barrier, no glowing wall marking the edge. It's an invisible surface defined not by what we can see, but by what we can no longer see. The moment light passes that boundary, it vanishes from our universe. It's still there in some sense, spiraling down into the black hole's singularity, but to us, it is gone. No signal, no message, no photon can ever escape once it crosses that threshold. This creates one of the strangest paradoxes in physics. From our perspective, as an object falls toward a black hole, it appears to slow down, time itself stretching toward infinity. Light emitted from it becomes redder and weaker until it fades entirely. But to the object itself, and to the photons caught in that fall, there's no pause. They cross the horizon in an instant, and from their perspective they never stop. It's as if two realities exist at once, one for the outside observer, where the horizon is an unreachable barrier, and one for whatever crosses it, where the barrier doesn't feel like a barrier at all. And this isn't the only horizon in the universe. There's another, far larger one, the cosmic horizon. This is the boundary of the observable universe, the farthest edge we can see. Beyond it, space is still there. Stars and galaxies still exist, but their light has not had enough time to reach us. The expansion of space is carrying them away faster than their photons can close the gap. To us, they are hidden behind a veil we will never pierce, not because the light doesn't exist, but because it will simply never arrive. These horizons remind us of something humbling. Even light, with all its speed and reach, is not infinite. It is bound by the structure of space-time itself. It cannot outrun the expansion of the universe. It cannot fight the gravity of a black hole. There are places where light simply cannot go. Or, if it goes, it never comes back. And yet these boundaries are not just limitations, they are also markers. They define the shape of our reality. The event horizon of a black hole shows us where gravity becomes so strong that space and time fold in on themselves. The cosmic horizon shows us how the expansion of space shapes the limits of our knowledge. Even though we cannot see beyond these horizons, they give us clues about the structure of the universe and the forces that govern it. For light, these horizons are like the edges of a map. Within the map, light is free, racing in every direction, weaving together the story of the cosmos. But at the edges, it stops. Not because it slows down or grows weak, but because the map itself runs out. Space stretches, gravity deepens, and the paths that light would take are cut off forever. Imagine standing at the edge of a black hole's event horizon. If you could hover there safely, you would see light from the universe distorted and warped, bent around the hole by its intense gravity. You would see the stars stretched and twisted, their photons dragged by the warping of space-time. But the moment you looked inward, past that invisible boundary, there would be only darkness. Light, which illuminates everything else, would be trapped in silence. The horizon is not just a place where light stops, it's a place where our knowledge ends. And yet, paradoxically, even in this silence, light still plays its part. The very existence of the horizon is revealed to us by light, the way it bends, the way it fades, the way it disappears. It is by watching what happens to photons near these cosmic edges that we learn where the boundaries of reality lie. Light, even in its absence, tells the story. But there's something else too, something even more strange. The universe itself might have a kind of horizon built into its fundamental nature. Some physicists think of reality like a hologram, with the true information of the universe encoded on its boundaries, not within its depths. If that's true, then horizons are not just places where light cannot cross. They may be where the deepest truths of the cosmos are written, where the information of everything is imprinted, waiting to be understood. Light shows us those boundaries, but it cannot go beyond them. It is both our guide and our limit. It draws the map for us, and then, at the edges, it simply stops. And there, beyond the reach of any photon, lies a place we cannot see, a place we may never see, and maybe that's what makes these horizons so haunting. They are not walls, not in any physical sense. They are the places where even light, the fastest, freest traveller in existence, must surrender. They are where the universe says this far and no farther. Imagine light, the swiftest thing in existence, gliding across the universe without pause. It is unstoppable, untouchable, and unyielding. Nothing can outrun it. Nothing can even keep pace with it. And yet, in the silent darkness of the cosmos, there are places where light meets its match, places where gravity becomes so overwhelming that even light, with all its speed and freedom, is bent, twisted, and ultimately trapped. These are black holes, regions of space where the rules of reality itself break down, and light is drawn into a fate it cannot escape. A black hole does not capture light in the way a net catches a fish. It doesn't chase after it. Instead, it bends the very fabric of space around it. The stronger the black hole's gravity, the more it distorts space-time, creating a slope so steep that light has no choice but to follow it downward. Light isn't being dragged, it's simply obeying the shape of the universe itself. To us, this looks like the ultimate trap, but to light there is no resistance, no fight. It's as if the road simply curves downward, and light, ever faithful to its straight-line path, follows the curve into darkness. As light approaches a black hole, its journey begins to change in ways that defy normal experience. From a distance, we can still see the photons that pass near the edge, bending around the hole's gravity in a process called gravitational lensing. This bending is so extreme that light from stars behind the black hole can be wrapped around it, creating arcs and rings of distorted brightness, a kind of cosmic mirage where space itself acts as a lens. But for photons that stray too close, there is no escape. At the event horizon, the boundary of the black hole, light meets a point of no return. It cannot slow down, it cannot turn back. It crosses that horizon in an instant and is lost to the outside universe forever. From our perspective, it simply vanishes, swallowed by the invisible edge. Yet for the photon itself, if we could imagine it having a point of view, there would be no change. It would simply continue forward, as it always does, unaware that it has passed a threshold that marks the end of its existence to any observer beyond. Even before light reaches the horizon, something remarkable happens. As photons fall toward a black hole, their energy is stretched by the intense gravity, a phenomenon known as gravitational redshift. Their wavelength grows longer, their colour fades toward the red, and eventually they slide out of the visible spectrum entirely, becoming invisible. The closer light gets to the horizon, the weaker and slower it appears to an outside observer, until it finally seems to freeze in place, hanging at the edge of darkness. But this is only what we see. In reality, the photon does not pause. It crosses the horizon, vanishes from our view, and continues its silent plunge toward the singularity. And inside that horizon, we don't know. No photon, no signal of any kind can ever escape to tell us. All our knowledge stops at that boundary. What happens to light once it is beyond the event horizon remains hidden. Does it spiral endlessly toward the singularity? Does it somehow imprint its information on the surface of the horizon itself, as some physicists suggest in the holographic principle? Or is it simply erased from existence, lost to the infinite compression at the core? These questions cut to the deepest mysteries of physics, where even our best theories are silent. Yet black holes do not merely consume light, they reshape it. Their gravitational pull warps entire regions of space, turning beams of light into curved paths, creating visual effects that defy logic. If you hovered near a black hole, safely outside the horizon, you would see the universe distorted. The stars would appear stretched and smeared into strange looping arcs. Some light would bend so far that it would circle the black hole multiple times before reaching your eyes. You could look forward and impossibly see the back of your own head, because the light that left you would have wrapped around the hole and returned. And in this bending and twisting of light, black holes reveal something profound about the universe. They show us that space is not a fixed stage, and light is not an untouchable traveller. Both are bound to the same deeper structure, the geometry of space-time. A black hole doesn't force light to obey it. It simply reshapes the road, and light, like an obedient traveller, follows the only path available. Yet, even as black holes consume light, they also create some of the brightest phenomena in the cosmos. Around their edges, matter falls inward, heating up as it spirals down. This infalling matter can emit light so intense that it outshines entire galaxies. Paradoxically, the regions around black holes, those cosmic voids of darkness, can also become beacons, marked by blinding radiation, jets of energy, and violent bursts of light hurled outward at nearly the speed of light. The black hole itself remains invisible, but its influence on light creates some of the most spectacular displays in the universe. Still, no matter how brilliant the light around a black hole may be, the horizon remains absolute. Nothing crosses it, and comes back. It is the ultimate one-way door, a boundary between the universe we know and a realm where our laws of physics fail. Light, the very thing that defines our sense of distance and time, vanishes there, as if it has reached the ultimate limit of reality. And yet, in its disappearance, light tells us something essential. By watching what happens to photons near a black hole, we glimpse the invisible. We see the way gravity can bend, stretch, and even consume the very fabric of existence. Light doesn't just fall into black holes, it marks their edges, outlines their invisible borders, and reveals their presence in the darkness. A black hole, in that sense, is not the death of light. It is its transformation. It turns light into a map, sketching out the most extreme corners of space-time, reminding us that even the universe's fastest traveller has its boundaries, and that beyond those boundaries lies a mystery so deep that even light itself cannot escape to tell us what it finds. If you could turn off every star in the sky, silence every galaxy, and remove every beam of light from the present-day universe, you would still be left with a faint, persistent glow. It isn't from any nearby source, and it isn't something you could see with your eyes. It's older than the oldest star, older than any planet, older even than the first galaxies. This light has been travelling for nearly 14 billion years, carrying with it the memory of the universe's very beginning. We call it the cosmic microwave background, the oldest light still moving through existence. This light was born in an era when the universe was young, unimaginably hot, and blindingly bright. In the first moments after the Big Bang, everything was packed together in a dense, searing plasma of particles and radiation. Back then, light couldn't move freely. Every photon was constantly colliding with matter, scattering endlessly in a chaotic fog. The universe wasn't transparent. It was more like a glowing storm where light could never escape. But then, something remarkable happened. About 380,000 years after the Big Bang, a blink in cosmic time, the universe cooled just enough for atoms to form. For the first time, electrons and protons came together, creating a clear and stable environment where light could finally travel unimpeded. In that moment, the fog lifted, the universe became transparent, and the photons that had been trapped in that storm of collisions were released. Those photons began to stream outward, racing into the vastness of space, and they've been travelling ever since. This is the light we now call the cosmic microwave background, or CMB. It is not bright. It is not sharp. It's a faint whisper stretched thin by billions of years of cosmic expansion, its once blazing energy cooled into microwaves, far beyond the reach of human vision. And yet, despite its faintness, it is everywhere. No matter where you look in the sky, no matter what direction you point your instruments, this ancient glow surrounds you. It is the echo of the universe's birth, still ringing softly through space. When we look at this light, we are not simply looking far away. We are looking back in time. Every photon in the cosmic microwave background is a traveller that has been moving across the universe for nearly the entire history of existence. It carries with it a map of the infant cosmos, frozen in place from the moment it was first released. Embedded in this light are subtle patterns, tiny variations in temperature and density, that tell the story of how the first structures of the universe began to form. From these ripples, galaxies would grow, stars would ignite, worlds would eventually come into being. This ancient light is, in many ways, the universe's memory. It doesn't change, it doesn't fade, and it doesn't forget. It has been stretched by the expansion of space itself, its wavelengths lengthened, its energy thinned out. But it is still here, still travelling, still wrapping around us like a quiet reminder of the moment when everything began. If light could see, this would be its longest journey, an endless trek across billions of years, never aging, never stopping, simply crossing the ever-expanding fabric of reality. And what's even more remarkable is that we can detect it. Using sensitive instruments, scientists have mapped this faint glow with extraordinary precision. What they found was astonishing. The cosmic microwave background is almost perfectly uniform, the same in every direction, with only tiny fluctuations. These fluctuations, little more than a few thousandths of a degree, are the fingerprints of the early universe. They are the seeds of everything we see today, the small differences that, over billions of years, would grow into galaxies, clusters of galaxies, and the vast cosmic web that stretches across space. It's humbling to realize that the light filling your microwave detectors tonight is the same light that began its journey before there were stars, before there were planets, before there was even the faintest concept of here and there. It has passed through an evolving universe, through epochs where galaxies formed, merged and collided, through ages where stars lived and died, scattering heavier elements into space. It has been present for every chapter of the universe's story, and it is still moving, still carrying its message across a cosmos that only grows larger with every passing moment. If you step outside on a clear night and look at the stars, you're seeing photons that may be thousands or millions of years old. But the cosmic microwave background is different. It is not just old, it is primordial. It belongs to a time before time, as we know it. It is the purest trace of the universe's birth, still glowing faintly, like an ember from a fire that once burned brighter than anything we can imagine. And here's the strange part. Though this light has been stretched thin, though it is faint and cold, it still surrounds us completely. Every point in space is bathed in it. The room you're in right now is filled with it. You cannot see it, but it's there, a quiet ocean of ancient photons washing through you, through the walls, through everything, always moving, always present. When we think about light, we often think about what it illuminates, the stars, the planets, the world in front of us. But this oldest light does something different. It doesn't light up objects. It reveals time itself. It shows us what the universe was before it became the universe we know. It is a window, not just to a faraway place, but to the first moment that light itself was free to move, and so this ancient light keeps travelling, crossing a universe that grows bigger every second, its wavelength stretched thinner and thinner by the expansion of space. It has no destination. It doesn't need one. It is simply the oldest journey still happening, a path without an end. And we, on this tiny planet in a quiet corner of the cosmos, are lucky enough to be able to see it, to read the story it carries, and to understand that even after nearly 14 billion years, this light is still on its way. If you want to understand the history of the universe, you don't need to dig through the ground or search for hidden ruins. You only need to follow the light. Every beam, every photon, every faint flicker crossing the vast expanse of space is a record of something that once happened. Light is not just illumination, it is memory. A memory that never fades, never slows, and never looks back. It travels forward, carrying with it a story that stretches across billions of years, written in a language of speed, colour and time. When you look up at the stars, you're looking at this memory. The light that shines down on you tonight has been travelling for years, centuries or even millennia. Some of it left its source long before there were cities on Earth, long before there were humans, long before there was even a planet for us to stand on. When you see a star that's 100 light years away, you're seeing it not as it is now, but as it was 100 years ago. When you look at a galaxy that's 1 billion light years away, you are witnessing an event that took place 1 billion years before this moment. Light is the only way we can see the past directly, not through imagination or reconstruction, but as it truly was. And that is what makes light such a powerful witness. Unlike us, it does not age or forget. A photon created in the violent heart of a star doesn't slow down, doesn't weaken as it travels across space. It simply moves, endlessly, until it meets something that can absorb it. A planet, a telescope, an eye. And in that moment of arrival, it delivers its message. It tells us, without words, about where it came from, about the conditions that created it, about the world it once left behind. This is why astronomers sometimes call light a time machine, because every photon we detect is a messenger from a different era. We do not see the universe as it is, we see it as it was. Every faint galaxy at the edge of our instruments is a glimpse into a chapter of cosmic history that happened billions of years ago. Light carries these moments forward, perfectly preserved, never altered by the passing of time because, for light, time doesn't pass at all. In this sense, light is the universe's memory because it remembers what nothing else can. The rocks and planets change, stars burn out, galaxies collide and reshape themselves. But the light they emit escapes, and in that escape it becomes a record. When it arrives, it carries that record with it. It is the imprint of a moment that can never be rewritten. Light does not rewrite history, it reveals it. This is also why the oldest light in the universe, the cosmic microwave background, is so profound. It isn't just ancient light. It's the first memory the universe ever created. A frozen snapshot from a time before stars, before galaxies, before anything familiar had formed. It is the closest thing we have to the universe's earliest thoughts, carried across nearly 14 billion years, unchanged and unbroken. When scientists study it, they are reading the oldest surviving record in existence. And yet, this isn't only true for the most distant and ancient light. Even the light around us now, from the sun, from the stars, from every glowing object, is part of this same stream of memory. The sunlight that warms your face left the sun about 8 minutes ago. That means that even in the most ordinary moment you are already surrounded by light that comes from the past. You live in a constant flood of memories, each one arriving at the speed of light, carrying the story of where it has been. But light doesn't just remember in distance and time, it remembers in colour. The spectrum of light carries information, the fingerprints of the atoms it has passed through, the temperature of the star it was born in, the way it was stretched by the expansion of the universe. Every shift in its wavelength is a clue, every tiny change a detail in the story. Scientists can read those clues the way historians read old texts. A single photon can tell you if a galaxy is racing away from us or falling toward us, if a star is young or old, if the universe was expanding faster or slower when that light first began its journey. And here's the strange part. This memory is not locked away in some unreachable archive. It is all around you, passing through the space you occupy, flooding the sky above your head every single night. The universe is not hiding its history. It is broadcasting it constantly in the form of light. All we need are the tools to decode it and the willingness to listen to what those photons are saying. In this way, light becomes something more than just a phenomenon of physics. It is the thread that binds the past to the present. It connects us to events so far away and so long ago that they feel almost impossible to imagine. Every time we see a star, we are not seeing it as it is now, but as it once was, preserved in a photon's endless journey. Light doesn't just show us where things are, it shows us when they were. It turns the night sky into a vast cosmic library, with every beam a page written long before we arrived. And there's something deeply humbling about that. Because in the end, we are part of this memory too. The light that leaves Earth tonight, from our cities, our telescopes, our own sun, will keep travelling long after we're gone. Perhaps one day, a distant observer, on some distant world, will catch a photon that left this planet in our time. And in that instant, they will see a faint, fragile memory of our world, carried by a beam of light that never forgot where it came from. Light, then, is not just the universe's memory. It is also our way of becoming part of it. Every photon that leaves this world is a record of our existence. Every beam of sunlight is a record of a star that has burned for billions of years. Every glow, every flicker, Every faint pulse across the void is a memory written into the fabric of reality itself, racing endlessly into the dark, never slowing, never stopping, and never forgetting. Every colour you see, every shadow, every shimmer of sunlight on water or glow from a distant star exists because of light. Without it, the world would be invisible, not just dark, but entirely without form. Light is the brush that paints our perception, and in many ways it creates the reality we believe we live in. Close your eyes for a moment and imagine a room. Without light, there is no colour. There is no shape. There are no edges to tell you where one object ends and another begins. The universe becomes a blank, undivided space. Now open your eyes again. Instantly light floods in, and the world is filled with structure. Shadows form where light is blocked. Colours emerge as light reflects from different surfaces. Textures become clear because of the way light bends and scatters. In that instant, light hasn't just illuminated the world, it has built it piece by piece for your mind to assemble. This is because our perception of reality is inseparable from light. What we call seeing is really an intricate process of decoding light. Photons bounce off objects, travel through the air, pass into your eyes, and trigger a chain of reactions that turn into sight. Your brain doesn't see the object itself. It sees the light that left it, or reflected off it, or escaped from it millions of years ago in the case of stars. Everything you see is an echo of photons reaching you, bringing information from somewhere else, and that means your entire visual world is a kind of translation, an interpretation of light's endless journey. The deep blue of the ocean, that is light, filtered and scattered by water. The soft glow of a sunset, that is light, stretched and reddened by the thickness of Earth's atmosphere. Even the blackness of space is not the absence of light, but a reminder of how little of it has reached you from that direction. Light doesn't just make the world visible, it dictates the world's appearance. It chooses what is revealed and what remains hidden. But light does more than create the images you see. It defines how you understand time and distance too. When you look at the moon, you're not seeing it as it is now. You're seeing it as it was just over a second ago, because that's how long it takes for its light to reach you. When you gaze at a distant star, you're seeing it as it was hundreds or thousands of years ago. Light doesn't just paint your perception in space. It stretches it backward in time. Every image in your mind is a frame from the past, projected forward into the present by photons. And light, in all its forms, bends reality in ways that are even stranger than we usually realize. It refracts, it reflects, it scatters. A glass of water can turn a straight straw into something that looks bent. Heat waves rising from a road can distort the air until light wavers like liquid. These aren't tricks. They're reminders that light is not passive. It doesn't simply travel through space and arrive at your eyes untouched. It is shaped, twisted, and filtered by everything it passes through. And in turn, it shapes and twists the way you see the world. Your perception is therefore not reality itself, but reality as filtered by light. The sky is not blue because the sky is inherently blue. It is blue because shorter wavelengths of sunlight scatter more effectively in Earth's atmosphere. A sunset is not red because the sun burns redder at evening. It is red because light at longer wavelengths survives its long journey through thickening air. Every colour you have ever seen is a story told by light, not about what a thing is, but about how photons have danced and shifted on their way to you. And perhaps the most extraordinary thing about this is how universal it is. Whether it's the faint glow of a galaxy 10 billion light years away, or the reflection off a leaf in your backyard, it's all the same language. Light carries information, and your mind turns that information into a world. Even if two people stand side by side, the world they see is slightly different, because their brains interpret those signals differently. Yet the light itself is always there, writing reality in a script that only perception can read. This is why, in a way, we don't just see with our eyes, we see with light itself. Light doesn't merely reveal the world, it constructs the stage, draws the outlines, fills in the details, and decides which parts remain invisible. Without it, there is no perception, no sense of shape, colour, or distance. Without it, even time would feel meaningless, because nothing could mark the passing of moments the way a shifting shadow or a deepening dusk does. And when you think of it like this, light is no longer just a physical phenomenon, it becomes something almost intimate, a bridge between the silent, indifferent universe and the world we experience. It has been travelling for billions of years, racing across impossible distances, only to arrive in your eyes and become part of your perception. In a way, every photon is a tiny messenger that has chosen you as its final destination. This is why the stars look the way they do. This is why the Milky Way glows across the night sky like spilled silver. This is why the world in daylight feels different from the world in twilight. Light paints not only the universe, but also the way we feel inside it. The warmth of a sunbeam, the cold shimmer of moonlight, the deep quiet of a sky full of stars. All of these are not just experiences. They are the result of light sculpting your perception into something you can live in. And in this sense, perception itself is a kind of memory written by light. Every time you open your eyes, you're reading what photons have carried to you, some born in the heart of the sun just minutes ago, others that began their journey billions of years before humans even existed. Light doesn't only shape what you see, it connects you in every moment to the vast history of the universe. Colour feels like one of the most real and certain parts of the world. We talk about the blue of the sky, the red of a rose, the green of a forest after rain, as if these colours exist out there, painted onto reality. But they don't. Not exactly. Colours are not properties of objects, and they're not embedded in the universe like stars in the night sky. Colours exist because we see them. They are born in the interaction between light, matter, and the mind that observes them. Imagine a beam of sunlight. Within it is every wavelength of visible light, from deep red to dazzling violet, and even beyond into ranges our eyes can never detect. When that light strikes an object, certain wavelengths are absorbed, and others bounce back. A leaf, for example, absorbs most wavelengths except green, which it reflects. But here's the strange part, that green isn't in the leaf. It isn't floating there in space, waiting to be picked up by your eyes. What actually reaches you is nothing more than a stream of photons, each carrying its own wavelength. Your eyes take in those wavelengths, and only then does green appear. Not in the leaf, not in the light, but in your perception. This is why two people can look at the same thing and see it slightly differently. The physics is the same. The photons bounce, they travel, they hit the retina. But the experience of colour, that vivid, immediate sense of red or blue, happens only in the brain. Without an observer, there is no colour. There are only wavelengths, invisible until a mind turns them into something we can feel. And it gets stranger. Consider colours we can't see. Ultraviolet, infrared, or the vast spectrum of light that stretches out in both directions beyond our limited vision. Bees see flowers in ultraviolet, patterns invisible to us but perfectly clear to them. Some birds see colours we don't even have names for, hues that don't exist in human language because our brains cannot process them. From our perspective, those colours don't exist at all, yet in another creature's world, they are as real and obvious as the blue of the midday sky. This means our world of colour is just a narrow slice of what light can do. The universe isn't painted in the palette we know. It's flooded with countless shades we can't perceive. But to us, reality feels complete, because light has been translated into the language our senses understand. The red of a sunset isn't really red. It's long wavelength light scattered by the atmosphere, interpreted by your brain as warmth and depth. The blue of the ocean isn't truly blue. It's water filtering out longer wavelengths, letting the shorter ones reach you. None of these colours exist out there. They bloom only in the moment of perception. This is why colour is not just a physical property, it is a collaboration between light and consciousness. Without photons, there is nothing to see. Without eyes and a brain to decode them, photons are simply energy moving through space. It's only in the meeting between light and perception that colour arises, vivid and undeniable. In that sense, colour is a kind of quiet illusion, not false, but not separate from the act of seeing either. If you could step outside your own perception and view the world purely as light, it would look nothing like the world you know. There would be no red apples or green leaves or golden sunsets. There would only be fields of radiation, each with its own wavelength and energy, none of them possessing the colours you recognise. The beauty we experience is not in the photons themselves, it is in what our minds make of them. And yet this illusion is not meaningless, it is how we survive. Colour allows us to tell ripe fruit from unripe, to notice danger in a flash of warning red, to track the shifting sky from dawn to dusk. It turns the raw, indifferent physics of light into something we can live in. A world of contrast and beauty, of soft blues and brilliant golds, of deep, endless black studded with stars. Even the stars themselves, if you look closely enough, reveal their colours. A young hot star shines blue-white. An older, cooler star glows orange or red. But those colours are not really there. They are clues, translations of temperature and composition into something our eyes can process. What we call colour is light's way of letting us read the universe in a language we instinctively understand. And perhaps the most fascinating part is this. Because colour depends on perception, it can be different for every observer. Some people are colourblind, their brains interpreting light differently, seeing fewer hues where others see many. Some animals see far more colours than we ever could. In a sense, each of us lives in our own version of the universe's palette, each one painted by the meeting of light and perception. So when you look at the world, at the endless blue of the sky, at the gold of sunlight through autumn leaves, at the crimson of a distant sunset, remember this: those colours exist only because you are here to see them. Light carries the potential for every hue, but it is your mind that completes the painting. Without you, without perception, the universe would still be filled with light, but it would be colourless, silent in its beauty. And maybe that's the quiet truth about colour. It doesn't exist until we see it, and yet it's the most intimate bridge between the physics of light and the experience of living. It is light's way of reminding us that reality is not only out there waiting to be measured, it's also in here, painted across the canvas of the mind. Consciousness feels like the one thing that belongs entirely to us. It's the quiet voice inside our minds, the part of us that thinks, feels, and wonders about the universe. And yet, when we look closer, when we peel away the layers of how the brain and body function, there's an unsettling question waiting there. Could consciousness, this thing we treat as private and immaterial, be connected to light itself? It's not as strange as it first sounds. Every thought, every memory, every flicker of awareness that passes through your mind happens because of electrical signals in the brain. Neurons fire, tiny currents surge, and in the spaces between those currents are electromagnetic fields. Fields that, like light, are part of the same fundamental force. The electricity in your brain, the glow of a lightning bolt, the light from a star, all of it comes from the same deep, universal structure of energy. When you see something, it begins with light. Photons enter your eyes, strike the retina, and trigger a cascade of reactions that become electrical impulses. Those impulses travel through a network of billions of neurons until, somehow, they create an experience. The colour of a sunset, the memory of a familiar face, the awareness of being here, now. Light doesn't just reveal the outside world to you, It becomes part of the process that allows you to experience it. Without it, your mind would never receive the raw data it needs to build a picture of reality. And here is where the boundary between physics and awareness begins to blur. If light is the messenger that carries information from the universe to our minds, then isn't consciousness in some way tied to light's journey? Not because light is consciousness, but because consciousness depends on it. The photons striking your eyes right now are part of an unbroken chain of events that began in the heart of stars, travelled across empty space, and ended by lighting up a thought inside your head. But there's an even stranger possibility, one that some scientists and philosophers have wondered about. What if consciousness itself emerges from the same kind of principles that govern light? Light doesn't experience time, it doesn't grow older. From the perspective of a photon, every point along its path exists in the same eternal now. What if awareness, the thing that feels like a single, indivisible moment of experience, shares something with that timeless quality? After all, consciousness doesn't move forward in pieces. You don't feel each fraction of a second click by like frames on a reel of film. You exist in a seamless present, a flow that never quite breaks. And light too exists outside of the normal flow of time. It doesn't wait. It doesn't age. It simply is. It's tempting, then, to wonder if what we experience as the now, that strange, ungraspable moment of awareness, might be closer in spirit to the way light moves through reality than to the way matter plods along through time. Some neuroscientists have even proposed that the electrical rhythms of the brain, those pulses of energy that generate our thoughts, might have something in common with the way light and electromagnetic fields interact. It's not that our minds are literally made of light, but that the same underlying forces might shape both. Your consciousness could be, in part, a pattern woven from the same fabric that lets photons race across the cosmos. And this brings us to a curious thought. If consciousness is linked, however faintly, to the same deep structure as light, does that mean our awareness is also bound to the fundamental limits light imposes on reality? If nothing can move faster than light, then perhaps even our thoughts, our perceptions, our very sense of the present moment are shaped by that limit, tied to the same cosmic speed limit that governs everything else. It's a humbling idea. It would mean that our awareness isn't separate from the universe at all. It isn't floating above it like something immaterial and detached. It's anchored in it, rooted in the same physical laws that guide photons through space and stars across galaxies. Consciousness, in this view, wouldn't just exist in the universe. It would be another expression of it. One more phenomenon bound by light's relentless, unchanging pace. And if that's true, then in every thought you have, in every moment of awareness, you're touching something far larger than yourself. You're part of the same story that began with the first burst of light at the dawn of time. Every neuron that fires in your brain, every photon that enters your eyes, every spark of perception, is one more thread in the vast, unbroken web of energy that has been weaving itself since the universe began. We don't know for certain if consciousness is bound to light in this way. Maybe it's only an echo of it, shaped by its rules but not defined by them. Or maybe it is deeper than that, a reflection of the same timeless quality that light seems to possess. A way for the universe to look back at itself, to become aware of the glow it has been casting into the dark for nearly 14 billion years. Either way, there is something quietly astonishing in the thought. When you see the world, when you think about it, when you simply exist in this present moment, you're moving in lockstep with the same phenomenon that carries light from the first stars to our skies. In that sense, perhaps consciousness doesn't just depend on light. Perhaps in some small and beautiful way it belongs to it. If you could slow the universe down to a whisper, quiet enough to hear the smallest exchanges of energy, you might begin to sense something extraordinary. A conversation that never stops. It's not a conversation in words or in any language we know. It is the endless, silent dialogue of photons, the carriers of light, exchanging their presence across the fabric of the cosmos. They are everywhere, and they are always in motion, weaving a tapestry of interactions that connects every point in the universe to every other. Every photon has a story. Some are born in the searing heart of a star, flung into space as the star burns its nuclear fuel. Others are created when matter collides with antimatter in a burst of pure energy. Some have been travelling for billions of years, their paths uninterrupted since the universe was young. Others are fleeting, appearing and vanishing in the blink of a quantum fluctuation. And yet, despite their countless different origins, every photon joins the same endless conversation, a constant flow of movement, scattering, reflection, and absorption, each event another line in an unbroken script. When a photon leaves a star and crosses empty space, it may pass near another star, bend slightly under gravity, and continue on. It may encounter a planet, strike its surface, and reflect. It may hit the atmosphere and scatter, turning a blue sky into a dome of diffused light. It may be absorbed by a leaf, driving the chemistry that allows life to exist. Or it may reach an eye, yours, and in that instant it becomes part of a thought, part of a memory, part of the human story. In this way, photons are not just pieces of energy, they are the universe's messengers, forever moving, forever interacting, forever shaping what can be known and seen. And the conversation never stops because every interaction spawns another. When light strikes a mirror, it bounces and changes direction, carrying new information about its encounter. When it scatters in a cloud, it splits and diffuses, turning sunlight into the soft white glow of an overcast day. When it passes near a black hole, it bends and stretches, distorted by gravity but never destroyed, its path altered, but its message intact. Each of these interactions is like an exchange, a photon brushing against matter and leaving behind a trace of its journey. This is why, in a sense, photons have been speaking to one another since the beginning. Not directly, not with intention, but through the chain of cause and effect that links every particle to every other. A photon emitted from a distant quasar billions of years ago might eventually strike a detector in a telescope on Earth. Having crossed an ocean of space and brushed against the gravitational pull of galaxies along the way, that single photon has carried the memory of that ancient quasar across time, and when it reaches us, it joins countless others in telling the story of the universe. Even here, in the most ordinary places this conversation is happening. Light reflects off the walls of your room, scatters off the air, and bounces from object to object before reaching your eyes. You are surrounded by a constant sea of photons, each one carrying information about the world around you, their paths intersecting, overlapping, merging into a quiet but infinite network of exchanges. We don't notice it, because it is so fundamental, so seamless, that it simply feels like reality itself. But in truth, it is light knitting together every visible thing in an endless luminous web. On a larger scale, these conversations shape the universe. Galaxies speak in light. Stars broadcast their life stories in colours and brightness, their photons telling us how hot they are, how old they are, and even how much longer they have to burn. When a star dies, it shouts its last words in brilliant flashes of light, scattering photons across space to be picked up by anyone, or anything, that might be watching, even billions of years later. And then there are the photons of the cosmic microwave background, the oldest light in existence. They have been travelling for nearly the entire age of the universe, carrying with them a record of its infancy. When we detect them, we are not just listening to light. We are eavesdropping on a conversation that began almost 14 billion years ago and has never once paused. If photons could think, if they could be aware of their endless journey, they would see a universe without separations. They would see no difference between here and there, no distinction between past and present. Every interaction would be part of one continuous thread. Every exchange part of an unbroken dialogue that stretches across space and time. In this way, the conversations of photons aren't just a poetic image. They're a description of how reality communicates with itself. We, as observers, are part of that dialogue too. When you look at the night sky and catch the light of a distant star, you're not simply watching. You're joining the conversation. Your eyes, your telescope, your mind. They become the final link in a chain that began eons ago. You're not separate from it. You're part of the same luminous story. And perhaps this is what light has been doing all along, weaving together the countless fragments of the universe into something whole. Every photon that travels, every reflection, every scattering, every flicker is a small act of connection, binding matter to matter, moment to moment, and mind to cosmos. It is an infinite conversation, and it has been happening since the very first light broke free from the darkness and began to move. If light could speak, its voice would not be loud. It wouldn't need to be. It has been talking for nearly 14 billion years without a single pause, carrying its message across the endless dark. And if we could hear it, truly hear it, perhaps it wouldn't sound like words at all, but like something older and simpler, a language of movement and presence, a story told not with sentences but with journeys. It might begin by telling us where it came from. A photon born in the heart of a star might whisper of the crushing heat that forged it, the nuclear fires where matter and energy trade places in an endless dance. It might tell of the moment it escaped, breaking free from the furnace of its birth to begin its long flight outward. For billions of years it has been travelling through space, never resting, never slowing. And in all that time, it has seen things that no living creature ever could. It might describe the galaxies it passed along the way, spiralling clusters of stars glowing in the blackness like lanterns on a sea without end. It might speak of the gravity wells of massive planets that tugged at its path, bending it ever so slightly but never stopping it. It might tell us about the vast gulfs of emptiness, stretches of space where it drifted alone for eons, unseen and untouched, until it found its way to an eye, a mirror, or a detector waiting to receive it. And if light could speak, maybe it would laugh at the idea of distance. To us, 1 billion light years is impossible to imagine. But for light, there is no long journey. From its perspective, there was never any time in between. It would say, I was there, and now I am here, and to me, there was no in-between. Perhaps that is why light is such a perfect witness to the universe. It does not age, it does not wait, it does not forget. It might tell us about the first moments when everything was new. The photons of the cosmic microwave background, the oldest light still moving, would speak in the faintest, most ancient voice. They would tell us of a time when the universe was nothing but a dense, searing fog, when space itself was small and hot and filled with energy. They would describe the moment when everything cooled, when the first atoms formed, and when they were finally free to travel outward. They have been speaking ever since, carrying that memory across the expanding cosmos, a message from the universe to itself. Light might also tell us what it has seen of us. It has bounced off the oceans of Earth, reflected from mountain snow, slid across the glass of our cities, and passed through the eyes of every living thing that has ever looked up at the sky. It has been captured in paintings, in telescopes, in photographs. Every sunset you have ever watched, every candle flame, every lightning flash. All of it was light, speaking in its quiet, wordless way. If light could speak, perhaps it would not speak only of motion but of connection. It might say, I am the bridge between everything, because light links the farthest galaxies to our eyes. It carries the memory of stars that died before Earth was born. It binds cause to effect, because nothing happens faster than light can move. In a sense, it is the universe's messenger and its boundary, the thread that ties space and time together in a single seamless fabric. And maybe light would ask us if we realize how much of it we're made of. Every atom in our bodies was forged in stars whose light once filled the darkness. We are creatures born of matter, but we're also beings who live by light. We see because of it. We know the cosmos because of it. Without light, there would be no perception, no memory, no way to witness anything at all. If light could speak, it might not sound like a lecture or a revelation. It might sound like something simpler, a quiet reminder. I have been here since the beginning. I'm still here now. I will be here long after you. And everything you know, everything you see, every story you tell depends on me. And maybe, if we listened closely enough, we would understand that light has been saying this all along, not in words but in the way it travels, in the way it fills the void between stars, in the way it arrives in our eyes after crossing 1 billion years. It has been speaking to us in every sunrise, every shadow, every distant starlit night. We have always been listening, we just didn't always know how to hear it. If light could speak, maybe it would simply say, I am the universe moving, and so are you. Time rules everything we know. It moves forward whether we want it to or not, ticking away in seconds, minutes, and years. We grow older under its steady pace, planets orbit in its rhythm, stars are born and die by its measure. And yet for light, time is not the same. In fact, for light, it may not exist at all. From our perspective, light races across the universe at nearly 300,000 kilometers per second. It travels for billions of years to reach us from the most distant galaxies. We look at it and see history, the deep past arriving in the present. But from light's own point of view, if such a thing could exist, that journey does not take billions of years. It takes no time at all. The instant a photon is emitted from its frame of reference, it arrives at its destination. There is no during, no in-between, no slow crawl through the fabric of time. For light, every point on its path exists in one single, unbroken moment. This is not poetry. It is what relativity tells us. The faster you move, the more time slows down relative to those who are not moving with you. Push that speed all the way to the speed of light, and time doesn't merely slow, it stops. A photon doesn't age. It doesn't experience the seconds passing. It doesn't know before or after. It exists in a kind of eternal present, where all distances collapse into now. Think of what this means. While we experience the universe as a sequence, just one event following another, light does not. The glow of a star that left its surface 10 billion years ago and the moment that same light enters your eye are, for the photon, one and the same. No waiting, no passage of ages, no gap to cross. This is why some physicists describe light as being outside time, or at least as close to timelessness as anything we can imagine. It is not bound to the same ticking clock that governs matter. We live inside time, but light moves in a way that makes time irrelevant. It is the nearest thing we have to a bridge between what is fleeting and what is eternal. Even the cosmic microwave background, the oldest light in existence, has been crossing the universe since the dawn of everything we know. To us, that's almost 14 billion years of travel. But from the perspective of that ancient light, if such a perspective could exist, it has not travelled for eons. It has never experienced a journey at all. It has simply been unchanged and ageless, slipping across space without ever feeling the passage of time it carries with it. And perhaps this is why light feels so fundamental, so absolute. It is not simply fast. It is anchored in a kind of stillness, a speed so great that it erases time altogether. It is the cosmic constant against which all other motion is measured. Matter slows, decays, and transforms under the weight of time, but light keeps moving as though time has no claim on it. If you could see the world as light does, you would not see a flowing river of moments. You would see the universe as one vast simultaneous whole, every point connected, every event coexisting in an unbroken now. Light doesn't merely move through space, it reveals a deeper truth, that time itself may not be as rigid and universal as we think. For light, the difference between then and now seems to vanish. And this is why light is not only the key to seeing the universe, it is also the key to understanding it. Light is the one thing that threads through the fabric of time without ever being bound to it. It is timelessness expressed as motion. When we look at the stars, we're not only looking into the past, we're peering into a state of being where past, present, and future are all stitched together by the unchanging speed of light. And in that sense, maybe this is the quiet lesson light has been carrying all along. While everything else is swept along by time's current, light has already reached the shore. It has always been there waiting for us to catch up. If you stop and think about it, you have been surrounded by light for your entire life. Every sunrise, every flicker of a candle, every reflection in a window, it has always been there, quietly shaping the world you see. But the truth is deeper than that. You're not only surrounded by light, you are made of it. Every atom in your body carries the memory of stars. Every element that makes you was forged in nuclear furnaces that burned so hot they filled the universe with light. You are, in the most literal way, a child of light. Long ago, the first stars collapsed under their own gravity, ignited, and began to shine. Inside their cores, hydrogen fused into helium, helium into heavier elements, until the materials that would one day form your bones and your blood were created in those blinding stellar hearts. When those stars died, they scattered their contents across space, mixing into clouds of dust and gas. From those clouds, new stars were born, planets formed, and eventually so did you. Every cell in your body is built from matter that was once illuminated from within by light. This means that the light you see in the sky is not something separate from you. It is not just a distant glow from unreachable stars. It is your history. The same physics that sends photons racing across the void is the same physics that forged the ingredients of your existence. To look at starlight is, in a way, to look at yourself, stretched across space and time, reflected back at you in a language older than memory. And yet, it's not only in your origins. Even now, light runs through you. When you eat, you're consuming energy that began as sunlight, captured by plants through photosynthesis, transformed into fuel for your body. The warmth in your skin, the spark in your thoughts, the electricity in your nerves, all of it can be traced back to light. Even your eyes, the instruments that let you see, are tools evolved to catch and read light's messages. Every moment of your awareness depends on photons entering you and becoming part of your perception. So what does it mean to be made of light? It means you are not separate from the universe that shines above you. You're connected to it in the most direct way possible. The starlight that crosses billions of years to reach your eyes is not just something you observe. It is kin to you. It is the same energy that shaped the cosmos, that gave rise to stars, planets, and eventually living beings who could look back at it in wonder. And maybe this is why light feels so fundamental, so quietly eternal. It doesn't age, it doesn't tire, it moves through the universe unchanging, while everything else, planets, stars, even entire galaxies, eventually fades. Light keeps going, and in some small way, so do you. Because the matter that makes you, the energy that animates you, and even the thoughts that flicker in your mind all exist because light has been moving, shaping, and connecting everything since the beginning of time. When you rest under the night sky, you're not just looking at the glow of faraway suns. You're resting in the same glow that once built you. You're surrounded by light that has been on a journey since before there were eyes to see it, before there were minds to wonder about it. And in that endless journey, there is a quiet kind of comfort, because if light is timeless, and if you are made from the things light has left behind, then some part of you is part of that same timelessness too. And maybe that's what light has been telling us all along, not in words, not in anything we can measure, but in the way it moves, in the way it reaches us across impossible distances, in the way it never stops. We are not separate from the glow of the universe. We are part of it. We live in it. we come from it. And even when we are gone, the light that has passed through us will keep on moving, carrying with it the faintest trace of who we were, folded into the same endless, unbroken radiance. In the end, to be made of light is not just a fact of physics. It's a reminder that you belong to the same story the stars have been telling since the beginning. And that story is still being written, photon by photon, moment by moment, in the quiet glow that never fades. And so, as we reach the end of this quiet journey, let the thoughts settle gently. You've always been surrounded by light. From the stars overhead to the glow that once burned in the cores of ancient suns and became the matter of your own body, it has been with you since the beginning. It has carried the memory of the universe across billions of years just to arrive here, in this moment, where you are. Light doesn't hurry, it doesn't struggle. It simply moves, unbound by time, unshaken by distance, connecting everything to everything else. And in its steady glow, there is a kind of peace, a reminder that the universe is not rushing anywhere, that it has been unfolding in its own quiet way for almost 14 billion years, and that you, for this brief and beautiful moment, are part of it. So if you are listening to this with your eyes growing heavy, let that thought carry you. Imagine the photons from distant stars falling softly across the darkness, as if the cosmos were tucking you in beneath its endless sky. Breathe, slowly, and know that nothing in this universe is truly separate. Not the stars, not the light, not you. Thank you for joining me here, for resting in this glow that has been shining since before time as we know it. And if this brought you a little calm tonight, feel free to stay, to listen again, or simply to let the quiet carry you into sleep. Until next time, may the light above you and the light within you remind you how vast and connected this universe truly is. Good night.